Good day, everybody. We're going to assume from first principles, meaning we're not going to use like the AM-GM inequality or Cauchy-Schwarz or anything too sophisticated, just basic axioms of inequalities. Now, I've seen this before. I like this superscript r greater than 0. It's a real number greater than 0. And one of the reasons this is important is if it's not greater than 0, you can reverse the sense of the inequality. For example, minus 6 is less than minus 3, right? But if you multiply by 3 by minus 1, you get 6 is, you multiply this, you get like that, right? Because multiply by negative 1 or multiply 2 by minus, and you get 3 is less than 6. So that's one of the properties of inequalities that's important. And as far as this proof goes, and just in general, but that's why we're assuming all the variables are positive. And when I say first principles, I mean no AM, GM. You may have heard of the arithmetic mean, geometric mean. There's Cauchy-Schwarz, super powerful, famous inequality. We're just going to do it from first principles, what we call first principles, okay? Now, and I'm not even going to glorify, a lot of people kind of pretentiously say without loss of generality here. They're numbers, they're positive numbers, and so you can order them. It's symmetric looking, so it's okay to just say this. You don't have to be too overboard by saying without loss of generality. All right. Now, so the first thing I'm going to do is just rewrite the left-hand side using laws of exponents, and that's what I mean by first principles. Nothing, just rudimentary stuff. Okay. Now, this very first term, let's just compare this this guy right here with this guy right here. Okay. This part is true. This object is greater than or equal to this object because y is less than or equal to x. And it's similar all the way across, right? So right here we're doing just a comparison. This underlying object, this underlying object. This underlying object is less than or equal to this because we've posited that we can order the real numbers that we're presented with. All right. Now, so that's you'll see that that's important because we have now this is kind of a general structure right here for what we're doing. But notice that we've also z is less than x, right? So if you multiply through by y, you would get what? Yz is less than or equal to yx, right? Then finally, if you multiply through by x, you get what we're talking about right here. You would get x, y, z. See, that's what I mean by first principles. Nothing sophisticated. See, and this is what they call a symmetric problem. You could rename the letters. It wouldn't change the fundamental truth that we're trying to convey right here. And so this is true, and that's why that would explain this part right here, okay, from here to here, right? And again, I'm not going to go through every bit of it, but it's that type of reasoning, right? But you see what we've gotten here by trichotomy, or what do they call it, transitivity? We have this is greater than or equal to this, but then up here we've proved that what we're trying to show is greater than or equal to the same thing. So you see, we've proved this result right up here, QED. I won't rewrite it, but if you just take a look at what we've written down, okay, we have this object being greater than or equal to 3xz, but we've shown that this very same object is less than or equal to x cubed plus y cubed is z cubed. So that proves this statement right here. So we've proven it just by using very basic elementary stuff. So again, let me know what you think. I've seen people try to prove the one, and I'll tell you since we have a little bit of time here. What I mean by the AM GM, to apply that here, it'd be very straightforward. You just do x cubed plus y cubed plus z cubed over 3. And this is like a pretty fundamental result here. It relates addition and multiplication. So I'm going to run out of room here. So this will be the cubed root of x cubed y cubed z cubed, right? But you see, you get, when you take the cubed root of all these objects cubed, you actually, and then bring it to the other side, you get the statement right here, right? Equality would happen if x equals y equals z. We see this is the statement of the arithmetic mean, geometric mean inequality. And if you multiply by 3 and then take the cube root, you have what we're trying to prove. So you can prove it essentially in 1 or 2 lines using a high-powered result, if you want to call the AMGM high-powered. But right here, we just did it without anything sophisticated, just very basic axioms of order. So anyway, that does it. Hope you enjoyed.